So when we talk about solving this partial differential equation which is involving the mixed partial derivative, so we have two ways. Either we start with integrating with y first and then with x, or we can start integrating with x first and then with y. But out of these two, which one we have to use can be checked from the given conditions. It's given that the condition is given for derivative of u with respect to x. The partial derivative of u with respect to x is given. It means we have to use this way. Okay. For shortcut, what you can do is, if you don't remember how to draw this diagram, for a shortcut, if the derivative with respect to x is given, start integrating with y, the other variable. So we integrate both sides with y. So what this will give you when you integrate it with y? So you have the second derivative of u, xy dy. It is equal integration of sine x cosine of y dy. Now when you are integrating with y, the derivative with respect to y get cancelled and you left with derivative of u with respect to x equal this term. Now when you are integrating it with respect to y, so what we will do with other variable? We are integrating with y. So the other variable, which is x, will be kept constant. This is the concept how we integrate with respect to one function, one variable, by considering other as a constant. So we have to integrate only cosine of x. So what is integral of cosine of y? It is sine y. Sine y. And sine of x being constant, we will not change it. We'll keep it same. Sine x plus, now here the constant of integration, which will be a function of x, the variable which was kept constant. Okay. Now we need to find the value of f of x. To find that value of f of x, we will make use of this condition. So this is your first condition. You can say condition number A, and this is condition number B, the second condition. It's obvious that why we are using this condition, not here, this one, because this is giving you the value of u. We don't have u here, but we have the partial derivative of u with x. So it means we have to use this condition. So using the condition that at y is equal to pi by 2, the partial derivative of u with respect to x as 2x, what we get? We use it in this equation and this will give you 2x equal sine of, see we have value only for y, we don't have value for x, so keep it same. Sine of x sine pi by 2 plus f of x. We know that sine pi by 2, that is sine 90, is 1. So this gives you 2x equal to sine x plus fx. This gives you the value of fx as 2x minus sine of x. So now we substitute this value of fx in this condition, in this equation. What we will get? Let me write it. Partial derivative of u with respect to x is equal to sine x sine y plus the value of fx, which is 2x minus sine of x. Now still we want to reach to u, so we have to integrate it again. So integrate both sides with respect to, now with respect to which variable? Here you don't need to think that it's x or y, because it's obvious from here. Since the derivative is with respect to x, So you have to integrate with respect to x. Okay, so what you will get on the left side, you will get it u is equal to integration of the term on the right side, sin x sin y plus 2x minus sin x. You have to integrate it with respect to x. So again we have the term of y inside, so we integrate with x considering y as a constant. So the only functions to integrate is sin x, 2x and sin x. What is integration of sin x? It is minus cosine x. Integration of 2x will be x square. Integration of minus sin x will be plus cosine x. And the other terms will remain same. So we get u is equal to minus cosine x sine of y plus x square plus cosine x plus the function of y. Okay, because y is the variable which was kept constant. Now to find the value of g of y, we will use equation B. So it is say that at x is equal to pi. So let's first write it on the next page. U is equal to minus of cosine x sin y plus x square plus cosine of x plus g of y. Okay, this is what we got. Now we have to use this initial condition. What is given? When x is pi, u is 2 sin y. So at x is equal to pi, u is 2 sin of y. Let's make use of this condition over here. So what we have to do? We replace x by pi. We replace x by pi, u by sine 2 sine of y, and we will keep y same. We don't change it. So let's put it here. So it is 2 sine of y equal minus cosine of, in place of x we have pi sine of y plus, in place of x we have the value pi square, in place of x again we have value cosine of pi plus g of y. Now we know that cosine of n pi is minus 1 to the power n for all n belong to the set of integers. Okay, so cosine of pi is equal to minus 1. So we replace this by minus 1 and this also by minus 1. So what you will get? 2 sine of y equal, minus minus become plus, sine of y plus pi square minus 1 plus g of y. Now we need to find the value of g of y. So we move remaining terms on the other side. So we get 2 sine of y. If I move this plus, it will become minus. This also become minus. And this minus 1 become plus 1. This is g of y. Again we can simplify these two terms. So this gives you sine of y minus pi square plus 1. This is the value of g of y. Now substitute this value of g of y here, which will give you the final solution. So we get u is equal to minus cosine x sine y plus x square plus cosine of x plus sine of y minus pi square plus 1. This is the final solution of the partial differential equation.